Hello all, today we are going to present a topic on time series analysis using ARIMA model. We, a group of 6 from Department of Data Science, Bishop College, developed the code for forecasting future values by using ARIMA model in Python programming. The agenda of the program is listed here and moving forward for the presentation section.
Hello guys, this is Sten Kulali. I'm going to talk about what is time series data and what are the several time series models that can be used for forecasting. What is time series data? Time series data is a type of data where observations are collected over time at regular intervals. In time series data, the values of a variable are recorded sequentially over time, such as hourly, daily, weekly, monthly, or yearly. There are several time series models that can be used for forecasting. They are autoregressive moving average model, autoregressive integrated moving average model, seasonal ARIMA model, vector autoregression model, and neural networks. In this project, we are using ARIMA model for analyzing and forecasting time series data. ARIMA is a most popular model for analyzing and forecasting time series data. It is particularly useful for non-stationary data and can capture both trends and cycles in the data. ARIMA stands for Autoregressive Integrated Moving Average. It is a statistical method used to analyze and forecast time series data. ARIMA models are commonly used in finance, economics, and other fields to predict future trends in datasets. ARIMA models are made up of three components: autoregression, integration, and moving average. The order of an ARIMA model is defined by three parameters: P, D, and Q. The parameter P is the order of the autoregressive component, which is the number of lagged values of the dependent variable included in the model. The parameter Q is the order of the moving average component, which is the number of lagged forecast errors included in the model. The parameter D is the degree of differencing, which is the number of times the data is differenced to make it stationary. Now let us see the three components in detail. First, autoregression component. This component is based on the idea that the value of a time series at any given point in time can be predicted by its previous values. The AR component is used to model the dependence of the time series on its past values. Integration component. This component is used to transform a non-stationary time series into a stationary one. A stationary time series is one whose statistical properties such as mean, variance do not change over time. The I component is used to remove the trend and seasonality from the time series. Moving average component. This component is used to model the dependence of the time series on its past error terms.
Hi, this is Mukesh Jaikumar. I'm here to explain about the difference between non-stationary time series and stationary time series. So stationary time series is one whose statistical properties such as mean, variance, and autocorrelation do not change over time. In other words, the distribution of the data remains the same throughout the time series. This means that a stationary time series has a constant mean and variance, and the correlation between any 2 points in the series depends only on the time lag between them and not on the absolute time at which they occur. Non-stationary time series. On the other hand, a non-stationary time series is one whose statistical properties change over time. This means that the mean, variance, and autocorrelation of the data change over time. Non-stationary time series can exhibit trends, cycles, and seasonal patterns. It is important to distinguish between stationary and non-stationary time series because many time series analysis techniques assume stationary. If a time series is non-stationary, it may be necessary to transform the data or use different analysis techniques to account for the changing statistical properties over time. So why stationary? Stationary is an important concept in time series analysis because it allows for more accurate modeling and predicting of the data. When a time series is stationary, it means that the statistical properties of the data do not change over time. This simplifies the analysis of the data, as it allows for the use of standard statistical techniques that assume stationary data. One key benefit of stationary time series is that it allows for the use of autoregressive models, that is AR models, and moving average models, MA models, which are widely used in time series analysis. These models assume that the data is stationary and they can accurately predict the relationships between data points and make predictions based on those relationships. In contrast, non-stationary time series can be more difficult to model and predict accurately because their statistical properties change over time. For example, a non-stationary time series may exhibit trends, cycles, or seasonal patterns which can make it difficult to identify the underlying patterns in the data. Therefore, identifying whether a time series is stationary or non-stationary is an important step in time series analysis.
Hi, I am Sandrapandi. I am here to explain about the difference between ARMA and ARIMA, are two commonly used models in time series analysis for modeling and forecasting data. ARMA model is a combination of autoregressive and moving average models. It assumes that the current value of a time series is a linear combination of past value and past errors. In other words, it assumes that the future values of the series are influenced by both the past values and the past errors. ARMA models are useful for stationary time series data that do not exhibit trend or seasonality. On the other hand, ARIMA is an extension of ARMA that includes the difference step. ARIMA models assume that the time series can be made stationary by taking differences between consecutive observation. This differencing steps removes the trend and seasonality from the series, making it easier to model and forecast. ARIMA models are therefore useful for non-stationary time series data that exhibits trends or seasonality. The parameters of an ARIMA model are represented as P, Q, where P is the order of the AR component and Q is the order of the MA component. The three parameters of the ARIMA model are represented as P, D, Q, where P is the order of AR model, D is the order of differencing, Q is the order of MA model. ARIMA model can also be extended to include seasonal components, resulting in SARIMA models. In summary, ARIMA models are useful for stationary time series that do not exhibit trend or seasonality, while ARIMA models are useful for non-stationary time series data that exhibits trend and or.
Myself, Eliarasan. I am here to explain the dataset. Why we are use dataset? A dataset is nothing but it contains a raw data or information. We have taken our time series dataset. It contains two columns. One is date column, another one is a date traffic columns. Our our time series dataset is about to how many people access the website in a day. A date column is defines time. The date traffic column is defines how many people access the website. The first step is drop a null value from a dataset using drop in a method. The next step is visualize the dataset because uh, dataset have only raw data. For visualization, it is very easy to understand. In visualization, we assign x-axis and y-axis. X-axis contain days and y-axis contains number of people's access, and then we can apply decomposition methods of time series. In time series, there are four components of decomposition method. They are trend, seasonality, cyclic, and irregular. And then we are used seasonal decompose method. The seasonal decompose method are nothing but it separates the time series data into the above four components. Uh, in a particular dataset, our time series dataset, there is an upward trend are present here and plot the dataset. And finally, we are using the machine learning model. We can split our dataset into training and testing part. We are split the 80% of data for training and 20% of data for testing and plot the training and testing data.
So this is Shruti from Department of Data Science. So far we have divided the data set into training and testing. So moving ahead, we are now checking for the stationarity of the data. So when a time series is stationary, it means that the statistical properties of the data do not differ over the time. So there are various methods to determine whether a time series is stationary or not. One way of doing this by means of visually inspecting by plotting the time series and checking the mean and variance of the time series. And second way of doing this by means of plotting ACF and PACF, which are significantly better than the above method. So third way is the very powerful method by means of taking a statistical test known as the augmented decay fuller test ADF test, which is way more powerful comparing the other two. So by means of this test, we can conclude if the p-value is less than 0.05, which is in fact the level of significance, we can conclude that time series is stationary. Perhaps if the p-value is greater than 0.05, the time series will be considered as non-stationary, and we have to further improve it by means of converting it to stationary. So moving forward, so these are the three ways to determine whether time series is stationary or not. So in a nutshell, we have to conclude that for checking stationary, there are three methods. First is by means of visually inspecting. Second is by means of using statistical plots such as ACF and PACF. Third is by means of statistical test known as ADF test. So moving forward to our dataset, we have to analyze whether it has stationary component or not. So by means of visually inspecting at a glance, we can clearly see that the mean is not at all constant and variance is not at all constant. The mean and the variance of the data differ over the time, denoting the non-stationarity property. So using statistical plots such as ACF and PACF also denote that the data has non-stationary as a part of it. So using a third way of doing this by means of ADF test, we can clearly see that the p-value is not at all less than 0.05. In fact, the value is 0.71, which clearly denotes that the data has non-stationary as a part of it. So hence from the above results, the time series is not stationary. So there are two ways of doing it: by means of turning into its stationary data and feeding it to the model, or by means of using differencing component D in ARIMA model to difference it and further converting into stationary and feeding it to the model. There are two ways, henceforth we have to do it by means of two ways. Obviously, the first way of doing it is by means of using first order differencing. So by means of doing first order differencing, we can see that the stationary property has further enhanced compared to the original plot. So we can, and also we have to plot the ACF and PACF, which shows a significant level of improvement comparing to the above method. So which in hand we can infer that from the autocorrelation plot that lag at which 4 is better performing and which can be fed into the ARIMA parameter, and partial autocorrelation function do not differ as from the above plot, it remains same. So we after differencing we can infer that autoregression at order 4 will be significantly helpful to determine the to forecast the data. The MA component, that is the PACF value, do not differ as much as from the plotting before differencing. So and obviously ADF test also shows that the significance level is 0.008, which is way more less than the 0.05, which is a significant level. So ADF test also signifies that the data after differencing shows stationarity property embedded in it. Henceforth, we made the model stationary. So after this, we can feed into ARIMA model, which in turn predict the future. So other way of doing this is by means of using ARIMA model, which further can pick the own parameters by means of hyperparameter tuning. So ARIMA is an automated version of ARIMA, that is the autoregressive integrated moving average model selection process. So it is a popular method for selecting the optimal order of ARIMA model for given time series data. So some advantages of using is by means of automated model selection by means of tuning its own P, Q, and D parameters, and by eliminating the need for manually selecting and repeating over, and also reduces the error prone and further increasing the accuracy of the model. So in Python, it can be implemented by means of using PMD ARIMA package, which in turn has a function known as AutoARIMA, which is used to tune our AutoARIMA model. So for input, I'm feeding the traffic column of the training dataset, and I'm flagging the seasonal component as false, as it do not have seasonality embedded in it. So after training the model, and I'm checking for the order at which the ARIMA suits our model well. So it is suggesting an ARIMA of 4, 1, 0, which can be emphasized as auto regression order of 4 and MA order of 0 and differencing by means of 1. This in turn can be interpreted as the number of autoregressive terms and degree of differencing and number of MA terms. So P is equal to 4 emphasizes that the model uses the value of series from the previous 4 time periods to predict the current value. And degree of differencing is equal to 1 means that the model uses first order differencing and to make it stationary. So Q is equal to 0 emphasizes that the model does not use the moving average at all to predict the future values. So P is equal to 4, D is equal to 1, Q is equal to 0 will be the optimum value for our ARIMA model to forecast the data. Further, we predict the data by means of testing set and forecasted the future values. So as we can clearly see, it captured the overall upward trend of the original data. So we can plot it against the original data and we can clearly note the upward trend, upward line going against the original data. So by me, the overall theme of this project is to capture the essence of ARIMA model, and its parameters P, Q, D can be captured by using of auto ARIMA model, which in turn should be the best fit by means of manually computing it. So this is the overall significance of auto ARIMA model and its fashion in capturing the non-stationarity of the data.
Hi, this is Shirley. I'm here to conclude our project. So far, we have implemented two main methods for exploiting the pattern behind time series data. One is manually using first order differencing and checking the stationary of the data, and the other is using AutoArima for stats model and further forecasting the future data. In conclusion, ARIMA is a popular time series model that can be used to model and forecast both stationary and non-stationary data. ARIMA models are versatile and flexible as they can incorporate autoregressive, moving average and differencing components to capture the patterns and trends in the data. ARIMA models can also be extended to include seasonal components, resulting in SARIMA, that is, seasonal ARIMA models, which are useful for modeling time series data with seasonal patterns. Overall, ARIMA models are widely used in various fields such as finance, economics, and engineering for modeling and forecasting time series data. The key advantages of using AutoArima include automated model selection, faster model selection, improved accuracy, flexibility, and user friendliness. Thank you.